Okay, let me turn off the light. Michael, I would like to make a important announcement. For next few weeks after the midterm, we're going to do some kind of participation. Probably we're going to do that every week. And one of the interesting perspectives I like to do participation is that you can bring your own computer, number one. And your computer will have some required environment, such as JSON, RPC, CPP. So you can actually, in the class, you can actually doing remote procedure call with a server I will provide them over here. So this means that I just want to let you know is that if you have a computer, bring it with you. And if your JSON, RPC, CPP doesn't work, no problem, because we're going to help you to install the hour after the class, which means that from 4 to 5 o'clock, we will actually get you set it up. It's actually on us about make sure you have the environment. If you do not have a computer, we can do a few things regarding, there are two options. If you don't have a computer, which means that because it's actually not required for you to actually have a laptop computer to take this class. So we have two options. One option is that you can use your phone, assuming you have a phone that you can access to run terminal. By the way, if you have an Android or I never try iPhone, but I try Android, that with my Android phone, I can have an emulation of a terminal. I can actually SSH into CSIF. And then from CSIF, I basically do everything. By the way, the CSIF environment is a Linux environment. That's option number one. Option number two is that we will provide some laptop in the class, which is already have JSON, RPC, CPP installed. And then during the lecture hour, you probably don't have time to come up here, but the hour after that, you can actually use that. But I hope that, I know most of you probably have your computer, so you might want to actually bring your own computer and your own laptop, and such that we will help you to make sure your environment is running. Okay, so that's something, but if you don't have computer, and if you have any concern about the process, please let me know. So essentially, I mean, I hope I can do this. I wish we could have done this today. I'm actually thinking about writing an online trick-or-treat program for today. And so your program will actually communicate the server to get a candy. It's not the real candy, sorry. It's a JSON candy, okay? I'm sorry that you take my course, you know that everything becomes JSON. The person is a JSON, the candy is a JSON as well, okay? Maybe next time I will make sure when I teach the same course, I will have whatever the JSON candy over there. And so you can actually send JSON candy to each other, of course. I feel that's a much safer way to do that. It's so unfortunate. I think some of us are from South Korea about, you know, what happened in South Korea a few days ago. It was just horrifies me. Yeah, I mean, I was actually in the area in Taiwan. Maybe 10 years ago, I was there. It's a very nice area. It's a lot of shop. I was there to purchase some souvenir. So when my Korean friend told me about what happened, because he was the one who actually took me to the same place. It was just, when I thought about that, I said, well, this is really unfortunate. The other thing is that for Halloween, let's do JSON exchange instead of doing the real candy exchange. Okay, so that's my announcement. I hope if you have any question, please let me know. Okay, you can let me know right after the class. Okay, the topic we talked about last time is exceptional handling, and I'm going to try to finish exceptional handling today, so I can move to. So just to let you know, this is we're trying to move in this direction. So after this topic, the next topic is actually we're going to, after chapter 15, we're going to cover chapter 8, chapter 9, and chapter 16, which is talk about class template. You have a question? Okay. No, that's okay. So just let you know for your reading, the next few chapters you should try to cover is chapter 8, chapter 9, and chapter 16. They're all talking about template. And in the template, I will talk about function pointer as well. I keep telling you, I promise you, I will talk about function pointer eventually when we talk about function template and lambda expression. Those topics are typically not covered, even for C programmer, ecs36b, they usually don't cover this topic, but it's great. When we talk about C++, we talk about function template, class template, and lambda expression and function pointer together. And those are the topics we'll be covering next, after exception. So let's try to finish exception today. Okay, so last time, we talked about this general framework about how do you actually set up for your program to capture the exception by having the 3 keywords. One is try, one is a throw, and one is catch. Try and the catch, they are mandatory. They have to be there because throw is kind of artificially, you try to generate a signal to be caught by the catch clause. But if you don't have the throw, sometime your program will actually have the throw statement being executed when some of the situation happen, just because of it's a runtime error. And let me show you one of the example by looking at this program. Okay, I'm going to show you this program. I hope you can actually take a look. You see this? Let me actually move it in the middle a little bit. Okay, this is a few lines of program. And you see I have a try. I have a try, I have a catch. But I don't have any throw, right? I have a try and catch, but I don't have any throw. And I like to give you a hint that the throw can be generated by the program itself. Can you actually look at this program and see what kind of situation that we might actually generate an exception in this piece of code? Yes, in the back.
Yeah, like when you try to make the new int, the long int, because there's not enough memory.
Right. Okay, so the memory allocation. Thank you. That's exactly right, because you see, I purposely put the M size here, M size times M. That means I'm actually creating a huge array of the integer, long integer object, and such that it might exhaustively took away. So for example, let me actually do this. If I make this 999, It's a fairly small number. And then I'll do a compiler. And I run it. Everything is good. M size is 999. And then that's fine. Okay, let's actually add a couple more digits here in the size. Let me add another 9. I think this one will still survive on my computer. Still okay. Then I add a few more. Okay, now I'm actually triggered the boundary. I don't have enough memory. You can see that now it's basically say, hey, by the way, if you look at the code, let me show you the code. I actually catch the first thing I print is inside the exception over here. So this is basically, I define my own catch and say that. And the thing is that the number 2 line is that I using, because every exception is, the exception is an object itself. I can remember exception handling that the catch clause is a function signature without the customized function name. So it's a catch, is the name. So it can only differentiate if you have the type about the parameter. So this one is exception class, but you can put the integer, you can put anything, or you can actually inherit from exception and then do something like that. So every exception must have a virtual function called what? Means that what is the exception message. And then there is another one, which is a useful function that this is essentially, there is a standard way to actually look at standard exceptions, like a memory allocation, and use this function called type ID on the E, and then basically say what's the standard exception type, the ID, and then print the name. And then we can actually see what's the result over here. So if you look at this result, this is a 3-line printing. This is the first line, is actually print inside of the exception. And the second line is a standard exception. You can see that this is actually the EWAT. So EWAT is actually called STD : bad allocation. That means your memory allocation is actually bad from the standard. But the type ID name, which is ST9 bad alloc. And this information sometimes is actually similar to this one, but it's actually have a special name that sometimes you can use that information as a string to actually do some kind of processing as well, further processing. Okay, so that's just we'll see the slides about each of the situations. So let me just show you this code again. You can see that between this try clause, that it might generate a runtime error condition, but this case is the bad allocation, means that you try to allocate the memory beyond the size of memory that the particular runtime environment can handle. So just give you a warning, the same program you're going to running on a different platform, running on a cloud versus running on a laptop or running on a mobile phone, that the memory limitation might be different. And therefore, sometimes it will generate the exception condition, and sometimes it won't. It depends. That's why this is kind of tricky, but this is also fun. It's supposed to be detecting what you have in your environment and decide how you like to handle that. Okay. Any question? All right. So I mentioned to you that there is a, oh, sorry. I show you this as an example that in the standard class exception, which is STD column exception, there are multiple standardized exception condition. And the first one we just show you is a bat underscore allocation. And you can see that every exception has this clause called what, which itself is a virtual function such that you can actually define a different what if you try to extend or inherit from the exception. Okay, so yeah, I think you already have this. You already have some of this. It's just allocation with a bunch of other things as well. Okay, we already see this program. You actually got that part. So by the way, you can do a rethrow as well. So meaning that I actually caught that particular program when I ask you, I enter a large number, and then it basically print out some of the routine. And the thing is that what you can do is that after you catch the exception, you can actually rethrow this exception. You can actually throw that E that you have, which means that if you have a multiple layer of catch clause, that it will be captured outside of the scope of the function as well. Okay, so if you notice that there is the screen that I'm actually showing you here is a little bit different from the screen I show you over here. If you run this program here, you see that the screen here is a little bit different from what you see in the slide. So I just want to tell you the difference is that this one is also actually running on top of a MacBook, but it's an earlier version, it's Intel-based MacBook. And the MacBook I'm using running at this moment is an ARM 64 MacBook. I mean, there is a big difference in terms of processor and the whole library, including JSON, including GDB, those kind of tool has been kind of recompiled. And some of this even without some changes. So therefore, even though it's a very similar operating system, that just be aware that sometimes the output is actually going to be quite different. Okay. Okay. The last one is that when you use this type name, and it will generate this string, as I show you that this is the string that's actually being generated. And the thing is that sometimes for this one, I want to use the standard up string for me to do that. But sometimes I can actually do polymorphic on that one. So I can generate a particular kind of string that I would like to handle the processing. That's why I sometimes use the type ID for me to do that. Okay, the last part is also very interesting, is the interference about exceptional handling between exception and multiple inheritance. That this is also, okay, let me actually ask you this. I have a two piece of code. I actually define something called my exception. And my exception is multiple inheritance from one of the class and also exception. So I do multiple inheritance on two of this class, and I create my exception. But I actually can write this code two different ways. What's the difference between the upper one and the lower one? What's the difference? They're both multiple inheritance from exception.
The class definition, you switch the order.
I switch the order about which one comes first, right? Okay, this is actually not necessarily the textbook. Your textbook actually talk about this case, but This is actually not universally true about this difference. But in general, if you put the exception for the second one, for some platform, not all the platform, this is again really bothering me as well, is that if you actually put it in the second one, that you actually realize that sometimes you have a uncaught exception error message that will be generated. So just to be safe, make sure your code will work. We always put the exception when you do multiple inheritance or virtual inheritance, you always do it in the first, okay? And if you write it this way, it will work for all the platforms. But if you switch, it might work, it might not work. Just be careful about that, okay? Okay, this is very artificial. Let me just show you the code. In my machine, again, in ARM64, it seems to me both ways is fine. But in the older Mac, Intel, it's actually, I have to put the exception first. Let me actually show you the code I wrote. So I have the code called ecs36b exception. Okay, I have this code. You can see how I did it. I have another class, which is just basically has some integer, whatever over there. And then I define a class, ecs36b exception, and public another and exception. So I basically inherit from the exception, and then I actually try to do a multiple inheritance very artificially, and to do that. And now I'm actually go to, I put this under shadow things.cpp. So you can actually get it from the GitHub about this piece of code. So what I did in the shadow thing, which is the JSON RPC stuff, I actually put include the ecs36b exception.h, and inside this dump to JSON. If you look at the way I did it, is that this is even in the older version. I have this. I have a try, and then I have a catch. When I do catch, I actually catch for ecs36b exception. Let me actually go back to the earlier version to get rid of this version to see how you can actually catch it. So this was the original one. I'm going to actually block this one. So this is the original version, which you try, and then you catch JSON RPC exception. So JSON RPC exception is also inherent from the exception E. And so it tries to catch it, but you can see that over here, after I comment out throw ecs36b exception, and it doesn't have any throw statement. So essentially, it's trying to catch the exception within this function. Okay, so let me actually try to compile it and run it and show you what happened. They're clean. Okay, so I'm going to go to run the server. And then I'm going to run the client. Yeah, I always thought I just run the program not too long ago. Okay, so when I run this program, HW5 client, HW5 server, there is nothing wrong, right? So that's fine. Okay, so there is a few things I can do. If I don't have the server, means I kill the server, and then I try to run client. You can see now I catch the exception. I call the exception saying that the client connector error, because I try to connect to 127.00.1 colon 8384, because the server is down, so I cannot do anything. So that's the exception that's actually catch by the exceptional handling. Okay, so that's case number one, but I want to check another case, which is interesting that you should probably know that you can do this. So I go to the server code, and I know the only function that matters right now is dump to JSON. So at the end of dump JSON, I'm supposed to return the result, which is the JSON encoding that I actually have this all along about, whether you can get this done. But instead of saying return result, I just say return 0. So essentially, I'm not returning a good JSON. I'm actually returning a integer to the client side. So let's actually see what happened. If I do make, now I'm actually running the server. I'm running the server, now I'm running the client. You see, that is another exception, but it's a different kind of exception. Now it says, it's not saying that it cannot connect to the 127.0.0.1. It's saying that the response is invalid because it's expecting a valid JSON string, which is the JSON value object it can convert it to, but it's not getting that. I'm getting something called 0 or whatever you input here, which is not a JSON. And that is another exception that's being caught by the program. So that's why you can actually take a look at this code. The exception routine I wrote is under shadow thing.cpp, which is a good thing when you actually write the code because you sometimes don't know what's happening on the other side. And also, especially over here, that this is something which is we try to catch for a throw that we didn't actually roll. It's actually inside the function. Let me actually see. Do they have that in the? Let me actually check one thing. Emacs minus NW HW5 client dot CP dot H. Sorry. Yeah, that's the routine. So this is the routine that's actually getting the result. You see that this result basically check when you call this method. Let me just tell you that this is a function called dump to JSON. This is, let me bring this to code that you know what's happening here. So inside here, I'm calling this function my client dot dump JSON. That's actually using remote procedure call. And that particular function dump to JSON is implemented inside the HW5.h, which is this piece of code was automatically generated. And as they always say, this is automatically generated by JSON RPC step, do not modify. And inside this function, there is inside this file, there is a function called dump to JSON, and is basically prepare the argument, and then it's actually calling the method and to remote. So this is the line that's actually connect the client with the server. So the server is actually going to do something and return this result. So you can see that the first line that I'm going to check is that I'm saying that whether the result is object, is a JSON object. Its object means that it's a JSON object. If that's true, you return the result. If false, means that it's not an object. In this case, it's 0. You can see that I just call JSON RPC exception. I throw that exception. So you can see that this function is inside the HW5 client.h. It will actually throw this and then print out the result over here. And that's how the mechanism works. That's why when inside this code dump to JSON, it has a throw. That's why it will be catch by this function here, over here. Okay. By the way, the other thing you can try is that if you actually remove this JSON RPC exception, you change that to the regular exception. By the way, this one won't be caught by this function because might or might not. Actually, I want you to try it. Okay. Okay, that's actually my very quick introduction to the exception, which is covered by the textbook, chapter 15. I believe I already covered all the important points in chapter 15. And please take a look at the program and try to get some experience about doing this. Okay. All right, now I think there's one more topic I want to cover. I will not cover this for now, but there is a topic regarding how you can handle segmentation fault using exception. I will not. I will actually come back to here after we talk about function pointer because it's related to that. Okay, so now I'm going to go to my second topic. The second topic today, this is my nice PowerPoint slide. I'm going to talk about function template and the class template. And the textbook I'm going to cover is chapter 8, chapter 9 first, and then go to chapter 16 of the textbook, which is function template, including class lambda expression, and then class template. And then I will talk about STL, which is the standard library. We have been using STD, CL, and those kind of routine, but now I'm going to cover STD, vector, and the map, and those kind of very powerful data structure. Okay. All right, so what is a function template? So function template is a concept for us to describe a set of functions using a standard format. And the only difference is that I will be able to apply the same format to different data type, including object type. So for example, don't like that to be blocked. Let me actually try to using this one is better. Yeah, okay. So in this case, you can see that I have the student in the back. Can you read it? Is this okay? All right, let me know if you cannot see it from the far, because I know this character is kind of smaller. Okay, I'm sorry that I want to avoid that being blocked. Okay, so I have two functions. One is actually taking the integer as a type. The other one is taking the double as a type. I might actually have another function looks like this. Another function, which is actually the same thing called minima, but I'm actually using the data type, like a GPS DG. Okay, I actually give you 3 examples. They are essentially the same with one another, except the data type. The only thing differentiate the 3 was data type.
You could also write multiple data types for the same, but I mean, like, we have a function that takes integer and double arguments, then I can just include another type name, right, to the template.
Yeah, you can include multiple type names. Yeah, for example, you can potentially have, so right now you can see that all the type names are the same, right? But you could have function with different type name as well. Yeah. Okay, so right now I give you an example that I only include one type name, but you could have multiple type name here as well. Okay, we'll see that in a moment. Okay, so this is the simplest one. So how do I actually describe this function? And I would just use this type name. So I just say the keyword is template, and then you provide a type name here. And then you actually, the type name will have some kind of T, some kind of argument. And then use this argument, you actually define what should be the t. So this is a template. You can see that. I can define a template looks like that. By the way, this is a running code. I'm actually saying that writing template and writing the type name, that's also a keyword with a red T. The T, you write a T because, okay, let me actually tell you, when you actually use this template, how do you use the template? This is the way you, let me see, no, not this one. When you use the template, this is the way to do it. You just say the template's name, and then with the type name you want to replace. So, which means that essentially what they're doing, the compiler is doing, is replace that double with that capital T. So essentially is replacing that and then generate the code. Okay, so look at this two line. This is basically a template, and this is the instantiation of the template, which is just you provide the type name. Let me give you a more complicated example. Any question for this? Yeah.
What if the arguments are just both ends? Do I still have to type ends like to initiate the function? Say if the arguments are already doubles, then I don't have to have the casting type or the init. If x is a double and then 2.7 is a double, then do we still have to write that I'm looking for the double template? It's the would understand and that they were both double.
I never tried. Good question. I never tried. I always include the type name there. And then because sometimes the compiler is going to do automatic conversion. Okay. I guess, okay, I have to try it, but my guess is it will not work because the templates, I believe, is resolved as a string replacement. It basically just replaces the string with whatever you have. It's like a preprocessor concept. So you don't, if you actually do not have that, they said, well, we cannot replace because they haven't done this automatic conversion, whatever that was a compiler is going to do, right? We're here is just basically replacing that code, the string replace. It's like a macro kind of concept. We can try it when I have time. I will actually try the program. I have about 10 minutes. I want to get a little bit further to that. So I could have a more complicated template. In this case, you can see that I have a template which has multiple type name. I can actually have a multiple type name, and each of the template is matching. So the first type name is matched to the first one, TRET, which is the return type. And then the target argument is a different type, and target argument 2 is a different one. So essentially, you can see that I could have a function. For example, when I call it, it looks like this because it's a function foo. It's actually returning a JSON value star. The first argument is a person object. The second argument is a JV time object. And then with a 2 parameter. So I could have a template looks like this. Okay. So let me actually see if I have a, okay. So let's actually look at this example. I think this is a good example to see practically how you can use the template with not just the type, but also with a value that you have. So this is an example from your textbook. Is that I want to write a function to decide what's the range of a particular variable I like to check. So the function itself only takes one argument, but I have 2 other values I want to get in to do the comparison. So how do I have that? Is, for example, this is the code I really want to have, which is in range, which basically return a Boolean, return true or false, and only one argument with a type, double or whatever, GPSDD, your choice. And then inside the function, what I want to implement is that whether this argument value is a smaller than 500 or is it greater than 0. It's a range you can decide. So this is a really good example to write a template, a function template, such that your function can be really, really flexible instead of try to do this kind of hard coding. So this is the way I will roll it in on the top. I hope you can see it. Yeah, you can see it. So you decide the template with 3 arguments. The first argument is just a type T, which you actually put here as a T. And then you have the upper and lower, which is the boundary that you have, the bound you have to put in. And then inside the function, you say that the argument need to be less than upper and then greater than lower. Okay, that's the parameter that the upper is going here and the lower is going here. So when you actually call this function, sorry about that, we actually call this function using the template. You just say is in range, and then the first one matched to this type name is a double, and then with the 500 and the 0. Okay. And in this case, have you noticed that in this case, I didn't put the return value data type into the template because I know it's always to be returning a bool. So the thing is the template, you only need to parameterize whatever data type you would like to do with this. So this is, you can think about if I can do this, I can actually easily replace this kind of function with whatever parameter you would like when you call it. Okay, so double 500 0 and put whatever value into that function, and then you complete the call. Okay, is that good? Yes, in the back. Yeah. I will put the GitHub. I haven't uploaded this set of form on the side. Thank you for reminding me. Okay. All right. Any other question? So now you have some idea about how to write the function template. Now I'm going to move to the next one, is pointer to function. I mean, how do you actually start to declare something is a pointer to a function? So here is the way to declare the pointer to a function. Let me say, assuming you have a function called is in range with this. Okay, this is the function that you have. And the thing is that when I want to define a pointer to either this function or any function share a similar function signature in their data type, I need to actually specify a data type. That's what we're going to do. And the thing is, what's the data type? The data type is the parameter, it's one parameter, it's a double. And it return, the data type is Boolean. So when you actually declare a variable, when you declare integer, you just say integer I, right? You declare integer I. But when you want to declare a function pointer to a function like this, then you say Boolean parenthesis star function pointer, I mean, or any name you want, and then you list the parameter name. And this line is basically declare a variable, which is a pointer. It's not only a pointer, but it's a pointer to a function of this kind of signature. So what you should do typically in your code looks like this. So after you define this, I can say function ptr is equal to, hold on, is equal to is in range, like this. Okay, so let me actually change it. I think you might thought that func pointer is a keyword. It's not. Let me call this fptr, and this one is fptr. So this one is declare, and this one is assign the value. What?
How do we use?
How do you use this? Great question. So now I can do that. Oh, sorry. How to call it is the next line. I'm actually going to call, assuming you have a Boolean value called B, I will say B is equal to, let me just say this. If, hey, Microsoft, can you not try to change everything I type into case? Okay, so I will just say star FPTR, and then is and range is a double, so I say 2.0. Oh, looks like this. So this is basically how to call the function. Call the function. And I need to remove the dot. Okay, so it's the same kind of format. This is how you declare that using provide the type. So you declare. I mean, this I feel in my at least personal experience, this is actually new to us. The way to declare it is probably the one that's actually kind of controversial, because we always think programming that when you declare a variable, it must be type, and then you have a variable. But in function pointer, the name of the variable is actually embedded in the middle. FPTR is really the variable. And it just half the line looks like this. So you can actually do FPTR. You can actually, by the way, to make it more readable for C programmer, sometimes we use type define. We can use type define for a pointer to function type. And then after that, then this will be probably more readable. Okay, so the 3 line, number 1 is how do you declare a function pointer? The second line is actually how to assign the value. So you have to assign the function name to that function pointer. So now you can actually do that. And the third one is how do you call it? Because it's a pointer, the pointer star is what we call dereferencing. So essentially, dereference the pointer, that becomes the function equivalent to the function, and then you put the parameter, and then just like that. Okay. Any question? So let's actually take a look at example. This is the same example I just wrote, but now it's a complete program that you can try. So I have a function is in range with the same thing you have seen this. And then I write the main program. The first line, I just declare the pointer. And the second one, I actually assign the value. And the third one, I just call it, and then like this, okay? Obviously, you can actually combine the function template with function pointer, and that will be interesting. Now you see that the point about function template is allow us to actually declare a general format as a function, but that particular function could be a pointer as well. And then when you have these two concepts together, you can actually create a code that's actually very powerful. And I'm not going to tell you that, but I'm going to go over this code later, which I already showed in the slide, is that instead of having that function is in range double, I actually wrote a template, the first part. And then over here, I'm actually using function pointer, but this one is kind of ugly because I have a template, but over here, this is not exactly matching all the template because I still have to, do this. And which means that we're going to see how we can address that issue next time on Wednesday. Okay, so I'm going to stop here. I think John is here. I will stay here as well. I know this week you guys are working on homework too. So yeah, we'll be here to help you.